Here we go. All right, I remembered. All right, so you can see on the agenda, there's a lot of things to discuss. Most of them will be pretty quick. Let me start at the reminders down at the bottom. Don't forget the positive physics unit 17 work is due tonight. And that is one thing that there was a little confusion on. I teach physics in a night class as well, but they're not always doing things at the same pace. And so they had their unit 17 section split into parts. And so initially I didn't recognize that I had copied over the same directions that they had into your direction. So if you saw in the description before I changed it, some of you noticed it used to say, like, just do certain parts of it, even though in class I said you're supposed to do all of it. You are supposed to do all of it, but I just wanted to make sure if you saw that early on before I got that change, that may have been confusing. So what I said in class is what I intended. Is for you to go ahead and do all of that. There is part of it you should have done on the Hooke's law because we did that earlier this semester, but the only thing that was missing, and it seemed like you didn't have to do the inquiry and review, but I do want you to do that because the review is great as we prepare for the exam, and the inquiry is good for thinking through lab type scenarios, sort of experimental type scenarios. So I do want you to do all of unit 17 in terms of the work section. So keep that in mind. And then the second reminder is about the physics test, which is also on positive physics, unit 23, the assessment. So what's due tonight is just the work section, so you kind of correct it as you go. But for the one that's due next Monday, that is an assessment. So you need to make sure you're doing that and then do as well as you can initially, finalize it when you're done, go back and correct it. And I do want, you can see in the agenda, the first thing here, I mentioned this yesterday, I do want you to verify that it's unlocked for you. I've had a few students that, it's only happened to 2 so far that I found, but I had a few students that for whatever reason, for them, it's locked. Everyone else is fine, but for a couple of them, it's been locked. So if you haven't been on positive physics to the unit 23 yet, make sure the assessment is unlocked. Actually, maybe I should type the word assessment just so you make sure you're recognizing it's not the work section. The work section is unlocked for all of them, but the assessment needs to be unlocked. And if it isn't, the site developer gave me a workaround to fix it for you. And so far that's worked for the 2 students that had the issue. All right, so double check that. Let me know if you're having trouble so that you're not scrambling around Monday with it locked trying to finish it. So, okay. The second thing, and another thing about that, it is a test which is higher percentage of your course grade than homework. So you do want to make sure that you're doing a great job and getting the best possible grade. I still have a few students who on the positive physics assessments are finishing it and then not going back and doing corrections. So that's the curve. So if you want to get that test grade curve, finalize it, then go back in, do your corrections, and I'll average those 2 percentages. So, all right, the second thing we need to do is next week we start our exam. And that'll start on Thursday, but I know that the seniors will be gone Monday and Tuesday. So I need to talk to you a little bit about that exam today so that the seniors don't miss out on that information Monday and Tuesday. I guess we only have 1 senior in this class, but I have another class with 8 seniors in it. So I just want to make sure that all seniors know everything and don't miss out on anything. So what I need to hear from each of you is, for the exam next Thursday and then the following Monday after that, do you plan to take our in-class exam online, or do you plan to come to campus and take it in person next Thursday and then the Monday after? Let me give you the protocol in case this would affect your decision. Let me just explain how it's going to work, and then you can give me your decision, what your plan is. So on Thursday, we'll be doing the FRQ portion. It has 4 FRQs. And normally on the AP exam, there are 5, and it usually goes short, long, long, short, short. That's the order of the 5 they give you. So I'm going to kind of mimic that with our 4 that we'll be doing, and it's just going to be short, long, long, short. Okay, so that'll be the order. The short questions are worth 7 points each. The long questions are worth 12 points each. And then after I add up your points, I actually put the grade in as a percentage. Okay. And so if you're coming on campus, you'll have a printout of those FRQ questions. And when you come in, the long questions are supposed to take 25 minutes and the short questions are supposed to take 13. So since there's 2 of each, that's 76 minutes and we have an 80-minute class. So when you come in, the test will just be kind of spread out. There will be copies of the AP formula sheet for you with the test. You'll just need to make sure you bring a calculator, or you can borrow one of mine if you choose, but probably be better if you use your own so you're familiar with it and everything, but there will be some backups. Bring pen or pencil. No requirement either way. I recommend pencil so you can easily correct your work, but your choice. And then if you're online, it'll be on the AP Classroom website. Everybody will be answering the same questions, but they'll be either on the website for you guys at home or on paper here. Now, the way you record your answers is different. If you're online, you'll be typing your answers into the AP Classroom website. All right, and that'll be required if you're doing it online. Okay. If you're doing it in class, you do have the choice of still doing that. If you would rather type your answers, you could still bring your device along in AP Classroom and just type your answers in like the people at home are doing. Or you can choose to put your answers on notebook paper, and I'll have notebook paper available. Okay, so if you're better at writing it out by hand, you can do that and just submit it as long as you're here in class. Okay, but I don't want pictures and images and stuff out on the internet because some of these questions are secured questions. So if you're doing it at home, you just have to show me your work in the browser. Okay, and on the AP Classroom website. And then the Monday after, we'll be doing the multiple choice portion. And the multiple choice portion will also be through AP Classroom. And if you're here, you'll again have a printout of those 42. There'll be 42 multiple choice questions. The first 40 are normal, 5 answers, 1 is correct. And then the last 2 are multiple correct, where there's 5 choices and 2 of the 5 are correct. Okay, so there's 42 multiple choice. And so if you're here, there will be a print version, so you can kind of read it on the paper and you can write it as you go. For both parts, if you're here in class, you'll have a print version that you can actually write on. Now, you can't take the print copies with you. Same, and that's not just because I don't want you to share it with somebody else, but again, they can't leave the classroom. So that's why if you're here, you have the opportunity to write on paper because it's never leaving the classroom. The test itself and your answer sheets are staying with me. If you're online, everything has to be done online. You can't print it. It doesn't allow you to. It's a secured browser. And so you have to type your answers in. There's no way to submit it otherwise. Okay, so that's the restriction. On the multiple choice, while in class you'll have a printout to follow along with, you'll also be putting your multiple choice answers in online. I just think that's cleaner and simpler than having you guys do a Scantron and they do it online. We'll just have that be the same for everybody. So on that Monday, if you're doing it from home, you'll just be doing it on AP Classroom again, and you'll be just reading the question and answering them as you go online. If you're here, you can do that, but there will be a print copy if that helps you. Okay, but it'll mostly be the same for the multiple choice part on Monday. All right, so that's the protocol. You can use a calculator on both parts, multiple choice and FRQ. You will have a copy of the formula sheet provided for you if you're here. If you're at home, you'll need to provide your own copy of the formula sheet, but in both cases, it needs to be a clean formula sheet with nothing else added. Okay, so for those of you at home, I'm just going to have to trust you'll follow the honor system and academic integrity and do that to satisfy that. But in class, you won't be able to use your own copy. You'll be having one provided that is clean with nothing else added to it. When we're finished with both parts, it'll be a percentage grade, and then that percentage will be curved. And this is the typical, I know for you guys on the screen, you may not be able to see this well, but I'll read it. This is the typical kind of breakdown for what the grades end up being. So if you score between 80 and 85% or higher, the cutoff for an A or a 5 in terms of College Board speak is usually around 80 to 85% traditionally year to year from College Board. The cutoff for a B is somewhere between 60 and 65%. Okay. The cutoff for a C is somewhere between 40 and 45% every year. Now, for your in-class exam, this will be the highest it could be. Okay, it will not be any higher than this, even if you all do great. Okay, it's based on, I put in factors that rate the difficulty level of the questions, and then it's a combination of a partly linear and partly non-linear graph that determines your grade that rank. So it's not a straight curve. It's like what a College Board uses. It's a weighted curve. So this will give you just an idea about where you should score to get a certain grade. But it might be slightly lower, like this top may drop down closer to 75. This could drop down closer to 55. This could drop down closer to 35. It'll just depend. I just finished my latest draft of the exam last night, so I'm still tweaking it and putting that into the spreadsheet. But and then part of it does factor in a little bit how the students do. And that's a small portion of it, but that does factor. So the curve won't actually be finalized until the exam is done, but it'll be something pretty close to that ratio. So that's the protocol. That's the plan. You'll be taking it during our class time. So if for some reason something comes up and you are unable to attend our class time due to some other emergency or whatever, then we'll have to work individually to see if you can maybe join one of my other classes or find a different time. But hopefully you'll all be able to take it in the normal class time. So now I need to know, what is your plan? Do you plan to take the in-class exam online, or do you take it in person, so that I know how many copies to make? This is a lot of paper and I don't want to make a whole bunch of extra copies and waste it, right? Because I just have to destroy them when we're done. So I don't want to waste any more paper than we need to now. And I also know that some of you say, hey, I plan to come in person, maybe you wake up sick or family emergency. So I know you can't, like, you're not signing a contract in blood here. I just want to know, what is your plan? And so I can try to be as conservative as I can on making copies. All right. I'll have one or two extra just in case someone changes their mind and shows up, but I don't want to have a whole bunch of extra. All right. So Jack, what is your plan for this in-class exam?
I think I'm coming to class.
Okay. All right. And Ethan?
Coming to class.
All right. Nat? You plan to come to class or take it online, Nat? Looks like she may be frozen. I'll come back to her. Evan?
Here.
Okay. Kyle?
In class.
All right. Johnny?
In class.
All right. Aiden?
In class.
All right.
Here.
All right. Rocky?
Online.
All right. Sally?
In class.
Okay. And Kate?
In class.
All right. And then hopefully Nat will be, oh, there she is. So it sounds like, look, I got a little connectivity issue there. Now, I don't know if you heard my question or not. Just trying to see if you plan to
But
take
in class.
in class. Okay.
I have to file.
All right. Very good.
I must not let these leak.
So again, if something comes up and it changes, just let me know as soon as you can. But if it's a last minute thing, you're not going to be penalized for that. So you don't need to be, distraught if something comes up. We'll still be able to work it out. All right. So I think that's all of the sort of housekeeping reminders plus info about the exam. Do you guys have any other questions you want to ask about the exam? You'll have, for those of you that are not seniors, you'll also have a chance to ask next week, but especially for Jack in this class. But any of you, if you have questions that you want to ask about the exam, now's a good time to ask. Clear enough? For now, clear as mud. Hopefully clear. Maybe not clear as distilled water, but. All right,
I think it'll be fine.
it'll be fine.
No
We'll
water.
be all right.
All right. One thing I do want to tell all of you guys, both those of you that are here in person, those of you that are in Zoom, even those that are watching the video, especially the international students that only can watch the video for the most part. You guys have done a good job of working hard this year. We've covered all the material. It's impossible to cover every kind of question they could ask, but I've tried to cover a wide variety and given you lots of suggestions through the year, and we have covered all the content. I know you're going to be well prepared, and you guys have impressed me with your ability to think through and solve problems. The things I would suggest to do to just continue to prepare both for our in-class and the actual College Board exam on May 5th, if you're taking it in person. Get on that AP Classroom site and make sure you can log into it. Make sure you kind of are familiar with the layout. I don't know that we'll have time to look at that today. So especially seniors, sometime between now and next Thursday, make sure you're logging in, checking to make sure that AP Classroom site works for you and you can see where things are. We'll probably take a little bit of time Monday and Tuesday in class next week and just open it up and let you kind of see it real quickly. But I don't think we're going to end up having time today. But make sure you're familiar with that. If you want to practice multiple choice questions on the AP Classroom site, if you haven't noticed it, there's an assessments tab. And in the assessments tab, there's topic questions for every unit. And so you can practice those to your heart's content. There's hundreds of multiple choice questions there for you to practice. And it tells you whether you're right or wrong. It grades it for you as you finish. So lots of practice that way if you want to do multiple choice. If you want to do FRQs, right now the best place is to look on Axis in the AP exam resources topic. And there's a bunch of FRQs from previous years and some other ones from the AP Classroom, like the ones we've been doing together. And they all come with scoring guides. So that would be the first option for practicing FRQs. Now, this weekend, they put out a notice that now the FRQs on the AP Classroom, for many of them, can be self-graded. So my hope for tonight and tomorrow is to go back to the Classroom website and find the ones that can be self-graded. I tried to look yesterday, I couldn't find a filter to help me identify it, but because some are secured and can't be, others are available. So I'm trying to figure out which ones you can self-grade. And then I'm going to make another assessment in the AP Classroom site of a sampling of FRQs that you could self-evaluate. But for right now, I'm still trying to figure out how that works because it's just a new functionality that just came up this weekend. So for now, your best option for FRQ practice is what I've provided on Axis. But keep an eye on that over the weekend or later this week. You'll probably see a new assessment in the assessments tab on the AP Classroom with some FRQs you could practice there too. There's also a practice exam, 2 practice exams in your textbook. The upside is they're in your textbook, so you got them. The downside is I don't know if the keys are there, so I'm not sure you can get a lot of feedback on. And the first one that's in the middle of the book only covers the first 9 chapters of the book, so it misses a few concepts. And the last one in the book covers electricity and waves, which aren't on the exam now anymore. So I wouldn't necessarily say that's your best option, but it's not a bad option. It still can give you some good practice. And then if you've purchased like a Barron's or Princeton or 5 Steps to a 5, that's yet another option. So all kinds of resources for you to review with. Yeah.
Is there a certain book, like one of those 5 Steps to a 5 thing, that you recommend over the others?
My favorite is the 5 Steps to a 5. And I may be a little biased just because I don't personally know the author, but I've seen a lot of his videos. And while he has a very eccentric personality, he really knows his stuff. And he's really good at explaining it clearly, in my opinion. So, and there's multiple levels of it. Like you can just get the print book that's just print. You can get the one that has online resources. If you get the elite version, it has like not only online practice tests, but all kinds of other resources. So, and it's not, I don't think, incredibly expensive. I think it's like maybe $5 more or something to get that one. So to me, the 5 Steps to a 5 is the best in my opinion.
Okay.
But I don't think any of them would be bad.
All right.
Yeah. All right. If you think of any other questions, let me know. Monday, for most of you that will be here, we'll be just continuing to review. I have on the agenda here number 6, FRQ from Unit 7. I mainly put it on here because I'm quite sure we won't get to that today. But I wanted to have it there to say, hey, seniors, so Jack, if you want to take it, I do have a print copy. And so for those that come to campus, you could grab up a print copy since you won't be here on Monday. For the rest of you, that's probably what we'll spend the majority of our time doing on Monday, is going through those 2 FRQs. There's a short one and a long one. And then we'll also practice some other kinds of questions. The main goal today is to do 4 and 5 to finish up the torque problem that we introduced a couple weeks ago now. I think it was before spring break. So I think a couple of you got pretty far along on that, and some of you didn't get very far yet because we didn't have a lot of time. If you did get far along or you finished it, you might want to just try question number 4 on that same worksheet while we're working on number 6. And I'll show you that question here in just a second. And then we're going to practice some momentum problems, since that's one of the latest topics we've covered that we didn't really get a lot of in-class practice with. Yeah, Aiden?
Are the two worksheets that we're gonna do over here?
Yeah, so the torque one is one we had from a while ago, but there's a couple extra copies. The momentum one is right here. And then the one we're gonna do probably Monday is also there, mainly just so seniors can grab it early if they want. All right, so let's go ahead and jump into that torque problem. So this is what it looks like. And like I said, you're the only class, we were a little bit ahead of the other classes, and you guys actually got to start on it early. So if you have finished it or got a good start on it, you won't need too much time. If you weren't here that day, or you just were kind of confused and couldn't really get a good start, here's another chance. And it's interesting. I was I guess it's not the final draft, but it's my latest draft of your exam. I was going through the multiple choice questions, and this exact picture showed up on one of the questions. I almost put it on there. It's like, oh, we're going over it in class. So, and then I thought, well, I want to test some things they haven't seen, because that's what the exam's going to be like. So I didn't put it on there, but this it's a very common type of question. So you very well could see it on the actual exam later. All right, so I'll give you about 10 minutes. If you've already finished it, like I said, you may want to try number 4, a different one that we haven't looked at yet. I think it's number 4.
I have an answer, but I don't remember if I got it right or wrong.
What did you get?
For A, it was 2,260 newtons,
Mhm.
and then B was 1,470.6 newtons.
That's not what I got for B.
Okay, so I think I got the first one right, or second one, yeah.
Okay. All right, so how many of you have an answer for either A or B? Few of you, okay. Kyle, what'd you get for A?
2048.
Okay, what'd you get for A?
I got one for B.
Oh, for B, what'd you get for B?
I have no idea how I got this, but somehow 3,920 newtons.
Okay, and then I saw Ethan's work and I've seen Kate's work. Anybody else in here have an answer?
I have answers.
What'd you get for A?
3,260.
Nice.
Okay,
Is that?
did you get B?
Is that wrong? Okay. B, I got 2,052 newtons and 44.9 degrees.
Okay, how about you guys in the Zoom? Any of you guys have answers yet, or are you still working? No answers yet? Okay. All right, so I've heard a few correct answers. I'm glad all of you worked through. This is a very complicated problem. Let me show you how I solved it. This is not the only way to solve it. Actually, when I did it the first time a couple of years ago, which was the first time I saw this particular problem, I did it one way on my paper. And that year I was trying to explain it to students in class using that way. And about 80% of them were completely confused, because the way I typically think of these problems is, instead of using the traditional formula FR sine theta, I always just figure out exactly what the component is that's perpendicular. It's just like the way my brain works. So, but all it did was confuse them. So I've resolved it using purely the equations that you're more familiar with, which is that FR sine theta for torque. And when I've explained it using this technique, more students say, okay, yeah, that makes sense. So I only say that because there's a lot of ways you could do it. You don't have to follow this sequence. Now, what I started with is just evaluating the picture. So hopefully you can see on the picture here the things that I've added. It is still sharing the screen for you guys on Zoom, right? You can see the picture here. Okay, good. So I started just thinking about what are the triangles that I could manipulate here, or evaluate here, really more than manipulate, I guess. Well, one they kind of gave us, they showed us that this is a 50-degree angle as it goes straight back to the wall, and that the tension would be the hypotenuse. So there's one right triangle. And then I can see that this makes a right triangle here. with the crate. And so because it's a right triangle, since the weight would be straight down, if that angle's 30, then this has to be 60. So I knew that. And then I noticed that this makes a Z, right? This is horizontal and then a diagonal, then a horizontal. So whenever you see that Z shape, you know that the opposite internal angles have to be equal. So if this is 30, then that has to be 30. So that helped me out. And then I started looking at part B, where it's asking about the force that the wall is exerting. And so I knew it would be probably somewhere kind of along the beam, maybe not necessarily exactly at the angle of the beam, but somewhere angled at some degree. And so it would have an X and a Y component, that it most likely wouldn't just be straight out. It could be, but then the X and the Y's would just, tell me that. And so I assumed it would have some angle and therefore a different X and a different Y component. I could find it and then determine the angle. So I just drew this other triangle here. That's not where I started. That's where I was going to finish, but I wanted to evaluate what everything was. Then I went to the force analysis, which is what I would always start with mathematically once I've analyzed the picture. And I recognize, okay, well, what are the up and down forces? So I just focused on vertical initially. I didn't even worry about horizontal yet. I just focused on the vertical forces. So I know the weight of this beam is going to be straight down, and I know the weight of this crate is going to be straight down. So those would be two downward forces. So I put those on one side of the equal sign, my force weight of the beam, weight of the crate, those two things were given. So those are my two downward vertical forces. And I know that this beam isn't rising or falling, so there must be upward forces that balance that. And this cable is going to help pull it up, but it's really only going to help pull this end up, right? So there has to be another upward force down here where that hinge is also pulling up. So I said, well, there's the Y component of the tension in the cable, and there's the Y component of that hinge on the wall. Those two would be the upward forces balancing these two downward forces. And I don't know what those are, but I know that that has to balance because this beam doesn't rise or fall. It stays fixed in its vertical position. Any questions about that force analysis or the picture, my extra triangulation features here on the picture? All right, so after the force analysis, then I picked the pivot point, which I've identified here with my little yellow mark. And I just picked the hinge because literally that would be the pivot point when they're setting this up. It would hinge until they got it at the right position that they wanted it in. I've seen questions like this where it's not a crate, but it's actually like a sign for a store or something. So it's a pretty common type of question, just with a different scenario. All right. So then I moved from forces into torque. And if I choose this as my axis of rotation, that means the wall's forces, which I absolutely know nothing about at this point in terms of their values, those don't create torque. So since I know nothing about them, that's kind of helpful because I can eliminate them from my torque consideration because those forces are at the point of rotation. And I know more about these forces, so it was, to me, logical to pick that point. You don't have to, though. You can pick the middle, you can pick other points. But one other thing that makes it, I think, helpful to pick this point is while we know that the beam is at a 30-degree angle to the horizontal, we don't necessarily know that this wall is or the hinge is pushing at the same angle that the beam is held at. We could assume it is, but that's an assumption that we don't really know. And so I didn't want to make that assumption, so I just said, well, I'm going to make that my point of rotation, therefore the wall's forces create no torque, and then I don't have to worry about that angle. So then I said, well, the tension in the cable is going to create torque that would make the beam rotate counterclockwise, whereas the weight of the beam and the weight of the crate are going to create torque that would cause the beam to rotate clockwise. And the beam doesn't rotate, so they must all be balanced. Those clockwise and counterclockwise torques must be balanced. And then I just started plugging in my FR sine theta information. So I don't know what the tension force is, so I just put FT for tension force. I know that if this is my axis of rotation, it is L, I just used L for the length of the beam. It's L distance from the axis. And I know that the angle this cable makes with the beam is 80 degrees because they told me this was 50. And based on my opposite internal thing, I know that this is 30. So 50 and 30 gives me the 80 that this cable makes with the beam. All right. A lot of times students will make the mistake of looking at this and saying, oh, that's 90. If you look closely, you can tell it isn't quite 90. And if you do the geometry, you can prove that it actually is 80. And then I went to the beam. I know the weight, it was given 1220, and I know it would be from the center of mass, which would be half the length of the beam. So I just put L/2, and its angle, that if I look at this as a triangle, this is 30. So this angle up here that the weight makes with the beam would be 60. And then the same thing for the crate. Its weight was given, and it's all the way out at the end. So it's L distance from the axis of rotation. And this angle has to be 60 because it's a right triangle. Okay, so that is how I plugged in all my values for torque. Any questions on that step? Trying to see if anybody's waving their hand over there in the Zoom pictures. All right, so next part then for me was just to start doing the algebra. Really at this point, I'm mostly done with the physics. I'm just algebra and trig from this point. So I just isolated FT. And so I took this sine of 80, which is about 0.984808, just rounded off, and the L, and I just divided both sides by that so I could get the tension force by itself. And then I just took 1220 times half times sine of 60 and got this 528.275. And then I took the 1960 times the sine of 60 and I got the 1697.41. So I just got rid of all my trig functions, and because I had all the angles, so I could just plug them into the calculator and get an actual number for all of them, and got rid of my half by dividing by 2 and just combined all the numbers so that all I have left are numbers with the L's. And at this point, I can see that what cancels. Yeah, we can factor out the L, divide by L on, and because we've got that in the denominator, that's going to cancel. And so if those L's cancel, all I have left is numbers on the right side of the equal sign. So if I just add the numerator values and divide by the denominator, I get rounded off the tension force 2260. So that's part A. Any questions about that? So for part B, finding the force of this hinge, it's going to have a vertical and a horizontal component. So I got to figure out, okay, well, what are those vertical and horizontal components? How am I going to calculate those? And so I just started drawing some triangles and figuring out what I could figure out. So this triangle is just recreating, let me go over here, it's easier to scroll than with my finger, it's easier to use the wheel on my mouse. So this triangle, I just recreated this red one up here. I just redrew it down below. So it's the 50-degree angle, the tension is the hypotenuse. I just redrew it down here. So now I know what the hypotenuse is, 2260. It's a 50-degree angle, so I didn't do it very well to scale here, but I just try to visualize it. And I know it's got an X and a Y component, so I just use sine and cosine. My Y component is 1730, my X component is 1450. So you might get slightly different values if you didn't round off as much as I did. So that's where you might get, you know, I got 45 degrees in the final answer, and some of you got like 44.8 or something. So it depends on how much you round off. So now I know the Y component for the tension force and the X component for the tension force. And if I look back up here at the top, when I was figuring out my forces here in green, I needed the Y component of the tension force, and eventually I need the Y component of the wall force. Well, using this triangle, I just found the Y component. Now I know this one. And so these two are given, and now I know this one, so I can solve for this one because it's the only one left. When you have three variables identified, that fourth one can be solved for. So I just rewrote my force equation here, plugged in my original values, and then now I added in this 1730 that we just found by doing this trig step here. And so then I can figure out the Y component of the wall. So now I have everything for my original force equation solved. Then I started thinking about, well, that's all been vertical so far. I didn't even think about horizontal yet. So I need to think about the horizontal forces. But if I go back up to the original picture, whoops, don't need to move that. If I go back up to the original picture, the only horizontal forces are this tension force of the cable is going to be pulling the beam back against the wall. And then therefore the hinge needs to be pushing against that. Right? That because that's the only force that's pulling in, and that's the only force that's pushing out. So those need to cancel. All right, so if those need to cancel, then that X component of the wall's force has to equal the X component of the tension. And we just found that here. So since we know the X component of the tension, that is the X component of the wall. And so now we've got two sides of the triangle. So we can find the hypotenuse, which is 20, 50. And because the two sides ended up being equal, we know that the angle is going to be 45. We can use the trig to prove it. And so depending on how you round, you might get like 44.8 or 44.9, something like that. I rounded off to the tens position all the way through just to keep it consistent. So, questions? All right. So the last thing I want to do here, and I don't know how much we'll have time to finish, but at least want to get started with it. If you haven't picked up the momentum equations problems worksheet over here, it's worksheet 6. Go ahead and do that. If you're on Zoom for you three ladies, if you want to go to topics, it's in unit 8 and it's worksheet 6. So unit 8 under topics, worksheet 6.
Find the momentum of the inelastic collision. That would be high.
And we're just gonna have you, divide up, and we'll have you three that are on Zoom. We'll have you guys trying question number 1 and seeing if you can work that through. And then we're gonna divide up some of the crew in here is going to also do number 1. We're just going to do 2 questions, kind of divide everybody up in either question 1 or question 2. So we won't, because we are kind of running out of time. So we'll have you guys in the breakout do question number 1. And then I'll probably have you share a little bit about how you were able to figure it out. So let me get a breakout here going. Have you guys found the worksheet, Rocky, Sally, and Nat? You found the right one? Okay. All right, so let me get you in a breakout room. You go ahead and start working on this railroad yard train question. All right, so and then here in class, let's have, let's just do it this way. Let's just have you guys here do question 2. So that's the question about the astronaut. And let's just go ahead and do a third one in case we have time. We may not have time to show all 3. But let's have you guys here in the back 4. Let's have you try the tennis player question. All right, they're all pretty similar, so see what you can come up with.
No.
Yeah, you can go up there if you want.
drifts into space.
You guys will be movie stars.
How much?
All right, so talk to us about how you figured out question 1.
Sorry, wait, can you put up a whiteboard for us to type on?
Actually, if you do it, then it gives you more control on writing on it. So just do share screen and choose whiteboard.
Okay, I can do that. All right. Okay. Let's see how this works. It's gonna let me type. Yeah, okay. So for part B, to find the speed, we know that the momentum at the beginning is going to have to equal the momentum when they collide. So our equation would be the first mass plus its velocity, or times its velocity, and then second mass times its velocity, and that's going to equal their masses together times their velocity at the end. So we know that the first one was 9,000 kilograms, and it gave us its velocity as 3 meters per second. And then the second one was loaded, and so we had to add the 5,000, so it would be 64,000 kilograms, but it was at rest, so its velocity is 0. And then their masses together is 73,000 kilograms, and then we're looking for their velocity. So doing algebra, we get that their velocity is 0.37 meters per second.
Great.
Nice.
Yeah, nicely done.
I can't edit, so I think I have to put up a whiteboard or.
Yeah. Okay, let me stop mine.
Okay. So this one's asking for the dissipated energy. So the kinetic energy of the train is 1/2 times the mass, which is 9,000 kilograms, times the velocity squared. So 3 meters per second squared, and you get 40,500 joules. And then the kinetic energy of the boxcar is just 0 because there's no velocity, there's no initial velocity. And then the kinetic energy at the end when they're combined is 1/2 times their masses together, which is 73,000 kilograms, times their velocity squared, which is 0.37 per second squared. And then you get 4,993 joules, and then you subtract the final from the kinetic energy in the beginning, and you get about 36,000 joules of dissipated energy.
Very good. Any other things from group 1? I think you guys explained it quite well, but is there anything else you want to add?
I was just supposed to say that we know this like conservation of momentum applies to the situation because both the carts are in an isolated system and therefore their net forces are 0.
Good. All right, nicely done. Let me share screen here and we'll have group 2 come up. We just have to go through it really quickly. So group 2, if you can
You want to see
talk
some?
to us about your question here.
All right, we have
Why don't you
this.
tell them what it's about?
So basically, it's about an astronaut. Oh, let me go to the side. So basically, it's about an astronaut and an empty oxygen tank, and he is departing with it.
Basically, since he's not moving at the beginning, the momentum is 0. So afterwards, the momentum of the tank equals the momentum of the person, and you plug in all the values that are given, and you just algebra. It's not a very difficult one.
Nice.
No,
So you got the mass of the tank is 20 times its velocity is 2. And then is that an equal sign?
Yeah, it got. I was going really fast.
Okay.
then
So it
it
equals
slowed.
the 80 times the V and you just solve for V?
Yeah.
All right, yeah, that was a pretty straightforward one. You guys got off easy. Nice. Okay, and then tennis player.
The picture was the
Let's
best
wrap
part.
this one up real quick.
no lie.
Speed run the tennis player.
Speed
You
run
want to
tennis
see some
player.
real speed?
Here comes the crew.
We have 30 seconds.
You guys want to explain?
Okay, so since momentum for the total change in momentum is mass times velocity, so we had the final velocity, or final momentum minus the initial momentum. So the mass times the final velocity in the backwards direction, so it's negative 25 meters per second, minus the mass times the initial velocity of 30 meters per second, which is negative 11 kilograms times meters per second. And then we find, so change in momentum is equal to force times time. So then the change momentum, negative 11 kilograms times meters per second, equals the time that it took to
Whack the ball.
yeah, is 0.5 seconds times force, and then just using algebra, you can get force equals negative 22 newtons.
Epic.
Yeah, nicely done. I like this one especially because it makes you think about the force impulse relationship and, sorry, the impulse momentum relationship. So good job. We are out of time. Rocky, Nat, and Sally, if you guys have questions for me, feel free to stick around. But if you don't, you're dismissed and we'll see you next week. Have a great rest of your day.
Thank you.
You're welcome. We're gonna stop the recording now.